All right, we are skipping lessons 83 and 84, and we're going right to 85. So this is Venn diagrams. So it says, suppose that 230 students play soccer, 190 students play basketball, and 60 students play both sports. There are a total of 500 students at the school. How many students play neither soccer nor basketball? All right, so I want you to take a minute and see if you can quickly calculate what you think it is. All right, so questions like this can be a little bit complicated sometimes. So usually it's good to have some sort of visual aid to help us. So we could use a two-way table like we learned in the last two lessons. And here we're going to use another type of visual aid, a Venn diagram, which you probably have seen in other courses, like maybe English or social studies when you're writing a comparative essay and you're trying to compare ideas. We can also use it in math. And sometimes we use it for amounts of people or things or whatever the subject happens to be. Or sometimes we use it for probabilities. So before we get into plugging it in for numbers, let's just go through the idea of what the parts of the Venn diagram are going to mean. So it says, let's look at the situation above more closely. At a high school, some students play soccer and some do not. Also, some students play basketball and some do not. This scenario can be represented by a Venn diagram as shown below. The circle labeled S represents the students who play soccer, and the circle labeled B represents all the students who play basketball. And the rectangle represents all the students at the school. So there's all these parts of the Venn diagram, right? And then, of course, we have this overlapped piece. So we want to shade the region of the Venn diagram that represents each of these things. So in example 1, it says on the Venn diagram provided, shade the region representing the students who play soccer. So if we're talking about the students who play soccer, it doesn't say only play soccer. So that means it's the whole S circle, including the overlapped piece. Okay, so if it's not specific, play soccer is that whole S circle. Okay, but do not play soccer. So if this is who is playing soccer, then everything else should be not soccer. Because remember, when you have the probability, if we're saying probability, of something happening and something not happening together should be one whole, right? So playing soccer, not playing soccer put together should represent the whole diagram. So basically everything except for that circle, including the rectangle and including this part of this circle, should all be colored in. So this way, if we were to put these two together, they would make the whole Venn diagram. Okay? Then play soccer and basketball. So remember, and has to be both. So they have to do both of those things, so it has to be in both of those circles. So the only thing that's both is that overlapped piece. Okay, so anytime they're talking about both at the same time, then that is going to be the middle. Or could be either one. They could play soccer only, they could play basketball only, or they could do both too. So or is going to be all of the circle parts together, even the middle. Sometimes people think you don't include the middle. You do. They are playing soccer. They're playing basketball. It had to be or. It could be both. Or includes both. And then play neither. We'll think about what or and nor mean, right? So or means it's either one. It could be soccer or basketball or both. Neither means they're not playing soccer. They're not playing basketball. They're not playing both. So it's everything except for those two circles. So it's the outside. So these are called complements when you can put them together and they add up to one whole. So like the play soccer and do not play soccer, they are called complements. These are complements and these are complements. And then this is plays soccer but does not play basketball. So we want the soccer circle, but we don't want the piece that's in the basketball. So that's just this piece. So this, they could have said plays only soccer, right? So if we were on only basketball, it would be this part of the circle without the overlapped piece. So that's the thing we have to look for. Okay? So now that we have this scenario, we could use this and go back and see what our answer is, which is what we're going to look at in the next example. Okay, so it says, think again about the school introduced in the do now. Suppose that 230 students play soccer, 190 students play basketball, and 60 students play both sports. There are a total of 500 students at the school. Complete the Venn diagram by writing the numbers of students in the various regions of the diagram. So let me just go back here for a second and just show you. You're going to fill a number in here, 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 and here. So there's 4 spots you're going to fill numbers in a Venn diagram. And if you know if you know the overlapped piece, usually that's the most helpful to fill in first. Okay, so going back to the example, 60 students play both sports. So anytime I have both, I usually start with that. So that goes in the middle. Because this is kind of deceiving if you're not careful when you're reading it. Suppose that 230 students play soccer. It didn't say only play soccer. It just says that they play soccer. If they all raise their hand, 230 of them would be raising their hand. Some of them just play soccer. Some of them play soccer and basketball, but that wasn't the question when they asked to raise their hand, right? So that 230 doesn't go here. That 230 is that whole entire circle. So I'm just going to make a little note here for myself that this piece of the circle and this piece of the circle have to add up to 230. So now that I think of it that way, well, if 60 of them are already playing basketball, then that means that there's 170 left. So that now 170 plus 60 gets me the 230, right? And then 190 students play basketball. It doesn't say that they only play basketball. It's just saying 190 play basketball. Well, we already have the 60 here that are doing both. So these two numbers have to add up to 190. And we already have the 60 there, so this is 130. So now we have to figure out, well, how many students are out here not playing soccer and not playing basketball? They're not doing either sport. So there are a total of 500 students at the school, right? So we have 170 plus 130, so it's 360. So there's 360 students that are playing soccer or basketball. And there's 500 total. So we're going to subtract. And that's going to leave us with 140 students outside. So now we have all the parts of a Venn diagram. So 1, 2, 3, 4 numbers that are labeled. So now we can answer the questions. How many students play basketball but not soccer? So basketball but not soccer. That's the 130. Suppose that a student will be selected at random from the school. What is the probability that the selected student plays neither sport? So this is how many students. This is the probability. So be careful of the questions. So this is just an amount. This is a number. But what is the probability that they play neither sport? That is out of the total. So there's 140 out of the 500. Okay? And then we can also fill in the probabilities. So sometimes you might see numbers, like quantities, in the Venn diagram like we have here. This is the amount of students. And then sometimes you might see probabilities in a Venn diagram. Yes, buddy?
Can you open this, please?
Yes. So if we have 170 students, that's out of 500. So 170 divided by 500, if I type that in, I get 0.34. So 34% chance, right? Then what if I took 60 out of 500? That's 0.12. That's a 12% chance. If I did 130 divided by 500, that's 0.26. And if I did 140 out of 500, that's 0.28. And now this is a Venn diagram of the same situation, just representing the probabilities of those things happening. So always make sure you're reading the question. Do they want the quantity or the probability? Now, if these are the probabilities, and this is representing all the situations, what do you think all those probabilities need to add up to? They need to add up to 1 whole, or 100% if you put it in as percents. Okay? All right, let's take a look at example 3. So this says some 10th graders at North High School take AP Bio, some students take AP World History, and some students take both. Let the event that a student takes AP Biology be represented by the letter B, and the event that a student takes AP World be represented by the letter W. The Venn diagram below shows the probabilities associated with the regions of this diagram. So in here we have the probabilities. So find the probability that a student takes AP Bio. Well, it's just saying that the student takes AP Bio. It doesn't say it has to be just AP Bio. It doesn't say it has to take both. It's just AP Bio. So that's the whole circle. So we want to add together the 0.45 plus the 0.25 and get 0.7. So 0.7 or 70%. Okay? Find the probability that a student takes AP World. So same thing. We want to add up the whole circle. So 0.25 plus 0.10 equals 0.35, or you can write 35%. And then find the probability that a student takes AP Bio or AP World. So remember, this middle is and. They take both. But or could be just AP Bio, just AP World, or they could be taking both of them. So when it's or, you're adding up everything inside of the circles. So you're adding up 0.45 plus 0.25 plus 0.10. So that's going to give me 0.7 plus 0.10, 0.8, or 80%. What's another way you could have found the probability that a student takes AP Bio or AP World? So look at this Venn diagram. Is there another way we could have figured out that it was 0.8 or 80%? So if it's or, then the complement to that, as we talked about before, would be neither, right? So this 0.2 out here is neither. These guys are taking neither one of these courses. So if I take my 1 whole, or 100%, and subtract that 0.2, I get 0.8, not a coincidence. Okay, so this plus this should add up to 1 whole. So now this is just probability, so I don't know how many students that is, but if they now tell me that there's 500 students in the school, how many students take both AP Biology and AP World? So the both is that 0.25, and if I multiply it by how many students there are, then I can figure out that there's 125 students that are taking both courses. Okay? All right. Last example, which says example 3, but it should be example 4. So this one says, in contract negotiations between a local government agency and its workers, it is estimated that there is a 50% chance that an agreement will be reached on the salaries of the workers. It is estimated that there is a 70% chance that there will be an agreement on the insurance benefits. There's a 20% chance that no agreement will be reached on either issue. Find the probability that an agreement will be reached on both issues. Based on this answer, determine whether the agreement on salaries and the agreement on insurance are independent events. So we're going to cross that out because that's what we skipped, and we're not going to get into independent events. So determine are independent. We don't need that whole thing. Okay. So we just want to focus on find the probability that an agreement will be reached on both issues. Okay, so this type of example is much easier when we have some sort of visual aid. So we can either use a Venn diagram or a two-way table to get a better view. Okay, so it's totally up to you. So I'm going to start this and have it set up for you so you kind of have an idea. And then I'm going to ask you to take a picture of either one or both of yours filled in and post it on Classroom in the classwork section. Okay, so you can either choose to do a Venn diagram or a two-way table, or you can send me a picture of both of them. Okay, so let's just set it up so you have an idea. So we have 50% chance that an agreement will be reached on the salaries of the workers. So salaries is something that we are talking about here. And there is a 70% chance that there will be an agreement on the insurance benefits. So we have two ideas, two events, salary and insurance. And then 20% chance that no agreement will be reached on either issue. Okay, so we know in a Venn diagram we have only salaries, we have both salary and insurance, we have only insurance, and we have neither salary nor insurance, right? Then in a two-way table, it's still salary and insurance. Doesn't matter which one is on which axis, right? But when we have a two-way table, we think of the is and is not, right? So salary is agreed upon, salary is not agreed upon. Insurance is agreed upon, insurance is not agreed upon. So that's when we use the is and is not. So we can say salary, no salary. Insurance, no insurance. And then we have our totals. Okay? So I want you to fill in either one or both and send a picture to the Classroom. I will make an assignment where you can add a picture of it. Okay? All right, and I will post the answer key tomorrow as well as the next lesson. Make sure you try the practice questions and the homework as well. Have a great day.